So welcome to Season 2 of Power On, the Reinhausen Podcast. I'm your host, Bob Very, and I'm the General Manager of Reinhausen Manufacturing, the U.S. subsidiary of Reinhausen. For those of you who don't know me, I'm a 32-year industry veteran in the energy industry. I've worked over many years in jobs with ABB, as well as working on the utility side with Duke Energy before joining Reinhausen in 2024. It's my pleasure to have with us today Fredi Belavić, asset manager from Austrian power grids. And Fredi, thank you so much for being here today.
Thank you for inviting me. It's a very nice pleasure.
Thank you so much. I just wanted to start out with maybe some softball questions, so just to get us warmed up. But I wanted to see if you could tell us a little bit about yourself and your role at APG.
My name is Fredi Belavić. I'm with APG since beginning of 2018. It means 6 years and a few months. I'm covering the role of asset manager, mostly responsible for the condition assessment of the power and instrument transformer, following the topics of maintenance and establishing new tools and improvement of maintenance of those assets. My previous background is something like 10, 12 years as a sales and application engineers in protection and control. Prior to that, I used to work as a regular power electrical engineer.
That's interesting. We actually have a similar background in that we both worked for OEMs in the industry and then came to work for a utility in the latter part of our career. So it's really quite interesting.
Yes, indeed.
Kind of great similarity. Now, can you describe your current responsibilities in asset management? So exactly what you focus on day to day?
So as already mentioned, I'm focused on the condition assessment of large power transformer, instrument transformers, and together with my colleagues, I'm working on the improvement on the maintenance strategy. In the past, we were following the time-based maintenance strategy. Now, with the introduction of the new tools, new diagnostics, we are trying to combine it with condition-based, maybe in the future predictive, but it's a long path, long way till there.
Now, did you find your background in protection and control helped you really prepare yourself for this role, really focusing on larger utility assets?
Definitely yes, because I implemented some knowledges or some practices from the protection business or work area into this new one. And I have to say that a lot of my colleagues welcomed these new ideas, new approach.
Yeah, I'm sure they did. I'm sure they did. Maybe you can provide us an overview of your organization, including its role in the regional energy grid, key infrastructure, and capacity.
Austrian Power Grid, APG, is an independent and transmission system operator running the high voltage level. In Austria, it means 110, 220, and 380 kilovolts. We operate something like 7,000 kilometers of lines distributed on 12,000 towers. Mm-hmm. We are operating approximately 70 substations on this voltage level, and in this day we commissioned our transformer number 100.
Oh, congratulations.
So it's a little, let's say, time to make some festivity as well.
Yeah, that's great.
The APG is, as mentioned, the transmission system operator. Now we are 900 employees. When I started 6 years ago, we have been 450. So it means there is a demand here for power network extension, and therefore we need people.
So I'm thinking about the people conversation. So what are some of the challenges that you have in getting talent into the organization, knowing that there's brain drain happening in the industry and people looking at different areas to work that are maybe a little bit more sexy than the utility industry. So what are some of your challenges in getting people?
It's a big challenge to get the skilled people because the people are not studying so much. The university are rather empty, especially we are talking about power engineering is not the disease of today, but from yesterday and the day before yesterday, when I used to study, the most interesting topic has been electronics, informatics, computer science, but not power engineering. But power engineering is, in my opinion, the basics for the development of the society as well. So we're trying to go to the schools, to the high schools, to the elementary school to motivate young people to get the challenge of studying power engineering or to be involved with that.
Mm-hmm. Mm-hmm. So it's been successful then. Obviously, you've doubled the size of your
organization. We are trying to do it. We have
a
big collaboration with two biggest university in Austria, in Vienna and Graz, and trying to recruit from them the good people. We are trying also to get some internships during the summer and to make some draft of the good students, good future engineers.
Great. That's a great way to bring in new people. So maybe you can highlight any of unique geographical or infrastructural features of the European region that impact your grid operations.
Austria is indeed in a Central Europe region, and we are affected with all changes which happens in European power network grid. Whatever it happen, if you have some changes of power load, power traffic from south to north, we are affected. From west to east, we are affected, vice versa as well. So it means that we have to dimension our network properly in order to not to be affected with those volatility and fluctuality, and also to implement a new modern tool which are regulating the frequency of 50 hertz. The demand has to be equalized with the generation. Otherwise, we have something what we don't want to have, a blackout.
Yes, nobody wants that. That's taboo in the utility industry. Now, as Austrian power grid is a central pillar in Austria's energy supply, what are currently the biggest challenges and opportunities facing your company?
So, as mentioned, one of the biggest challenges are, of course, manpower, getting skilled professionals in all areas, not only in power engineering, but also supporting, let's call them shared services, IT, legal, market, and so on. That's one point. The big challenge is also the shortage of the equipment, because everybody are expanding the network, not only Austria. And the biggest challenge is also to build the new network in order to get the demand of the future, to make it fit, to make a new power lines, to make a new substation in order to have the possibility to integrate the renewables and, as mentioned previously, to make possible the power transfer through the country from all the sides.
Do you have similar challenges in Austria with land acquisition and trying to secure either the land for substations or the land for transmission lines? And how do you overcome that?
Definitely. It's pretty big challenge as well. So we are trying to secure the lands, but the people are not willing to sell the land. The prices are sometimes not very in relationship with what is the actual value. Then another challenge is that maybe probably you have some other infrastructural project already planned on a certain area. Of course, it's very nice to have a substation and lines close to the wind power farms, but you still have to have some distance, safety corridor between those infrastructures. So there are the challenges which you recognized very well.
Yeah, I can imagine. I've seen it just with my time at Duke Energy. Now, you mentioned about transformers and lead times, but how are you managing through that as you look at yourself as a utility, and not just transformers, but just infrastructure equipment in general? How are you managing through that to get your projects completed?
Generally, we are planning on middle and long term. It's a middle long-term planning strategy. What we are performing in asset management, we are in continuous discussion or conversation or dialogue with the suppliers. We are getting our demand known. So in order that they can also predict the production and to make the resources available.
Right.
It's, let's say, the old good strategy, but what happened in the last few years, we can say since pandemic, is that the lead times have been extremely longer. So it means that we have to adapt ourselves as well and to plan even earlier and even on longer term.
Yeah. Yeah. And I can imagine that planning cycle just creates challenges in itself, and that you're trying to predict the future so far out, you're not sure exactly what's going to happen and what's going to change. So one of the questions that I wanted to ask was, could you explain the decision behind the development of the 380 kV ring network in Austria? And also, is there a plan to further expand the network, especially with the integration of renewable energy resources?
Yeah, with pleasure. The fact is that the demand of the energy is arising. With the existing infrastructure, we cannot cover it. So we do need to enlarge the grid. Historical background of Austria is that we started with 220 kV. In 74, it was the begin of the 380 kV line project in Austria.
Oh, wow.
And now we are trying to close the ring across Austria in order to be able to transmit those energy. Of course, higher voltage level means lower losses and the possibility of transportation of much more energy.
Right.
Together with that, there are challenges where to build it. There are some regional geographical concerns.
Right.
We have Alps, we have mountains. So it means we can build a new lines or new substation only in the valleys, but the valleys are already congested. There are some people living there, and rather less people want to have a tower in front of the garden.
Of course. Yeah, exactly. Yeah, it doesn't look the same with a tower in front.
I think that the problem or the challenges are worldwide the same.
Yeah.
If you have some problem with the space, with the area.
Has it forced you to look more at undergrounding, or is it really not practical to do that in Austria?
It's not so practical in Austria because the geographical conditions are so you cannot go underground through the mountains. You have to make some tunnels. And the fact is that the power supply stability is, in our opinion, much, much higher if we are dealing with overhead lines instead of underground cables.
Right. Now, I think when you mention about the expansion, especially of the 380 kV grid, we think about the different weather events that have happened around the world. And most recently, the flooding that took place in Austria, Czech Republic, and Romania. But how do you prepare your infrastructure to withstand not only the current, but the future extreme weather events?
We are monitoring all those things, and we are changing a little bit also the paradigm, how the grid or where the grid will be extended. The conditions are changing. In the past, we were much more focused on the snow avalanches. Now we have to watch on problem with landslides.
Yeah.
And it means that we have to choose to select our routes for our new lines so that not affected of these catastrophical events. To reinforce it eventually, or not to put the towers there where is a potential risk. We are performing plenty of studies together with some other companies or societies in Austria, with the universities, in order to get the best results and not to affect the power supply security.
Now, you're also doing peer benchmarking, so you're actually talking with other utilities that are going through these same type of evaluations, not only in Europe, but in other countries?
Definitely. We are talking with another utilities which are in the same boat as we are.
Sure.
Dealing with the same climatic or geographical conditions. And we are talking also with the utilities in far south, like Spain or Portugal or Greece, if we are talking about wood fires and something like that. Because Fortunately, we don't have experience with that, but we could expect, because of the global warming, that also these catastrophic issues could happen in Austria as well.
Yeah, certainly. And I think everybody needs to take another look with all the events that are taking place around the globe at what risks they have and how do they manage that going forward. So you're doing all the right things if you look at that and how you're collaborating with others.
Thanks.
Yeah. So just there's a number of projects that are listed on your website, and I'd like to take a closer look at two of them with you if we can. One mentions the secure power supply in the central region of Upper Austria. The project aims to support the electrification of the economy and society in Upper Austria. What are the particular challenges involved with integrating renewable energy and simultaneously security in a booming economic region?
So the Upper Austria is the focus, is the central of industry, we can say, in Austria. Mm-hmm. Biggest steel factory is placed there, and they are, let's say, the catalyst, the motivator for the Green Deal as well, because they are moving from a conventional way of producing steel using coal to electricity, and in order to have electricity, we have to support them with expanding the grid. Mm-hmm. The fact is also that in the past, along the Danube, there were a plenty of hydropower plants. Still, very important part of power supply in Austria, but they are not enough to cover this demand. So it means that you have to transfer the energy generated by the renewables, which is in the east of the country, photovoltaic and wind energy, to those consumer.
Right.
And that means that we have to build new lines or reinforce it to build new substations, and that is how we are contributing in a Green Deal.
Okay. So it's really getting the energy that's produced somewhere else to the load centers that need the production
correct
for their own industries.
As mentioned previously, those area is already congested by industry, by the cities, and you don't have any possibility to place there some biggest generation facilities.
Yeah, exactly. And it's interesting. I do a lot of reading on what's going on in the industry, and it's clear that challenge is everywhere. It's, where you need the power and where you can produce the power in two different places in most of the cases. And, whether it's the Austrian power grid or, Mid-American energy in the upper plains of the United States, they're running through the same issues and trying to get energy where it's needed and the challenges with getting renewables where they're needed.
Austrian power grid doesn't own the energy. We are only transmitting it.
Exactly.
Because the liberalization, regulation in Austria and the European community were not allowed to generate, but we are here to facilitate the transmission and distribution of the electrical energy.
Right. You're the extension cord.
Yes, we are the highway.
The highway. That's better. Better analogy. I like that better. So the other one I wanted to probe into was the article on decarbonization and grid stability. So one of the EU's core objectives is decarbonization without compromising security of supply. So how does APG support these ambitions with its projects, such as the West-Tyrol cell sealer upgrade? And what roles do cooperation with other grid operators in Europe play in this?
All those projects are coordinated on the European level, following the TYNDP, 10 years network development plan, which is published and coordinated also by the European Community and NSOE.
Okay.
So the fact is that the biggest hydro generation, or one of the biggest hydro generation what we have, is in the Alps, as mentioned in Zell-am-Ziller, and the project of West-Tyrol, it's the focal point from which the energy has been produced or generated in narrow valleys could be spread across the Europe to the western part, from point of view of West-Tyrol to Switzerland as well, or to Italy in southern, or north to Germany, or to the east in the rest of Austria.
Right. So it really can be used anywhere within close proximity to the Austrian grid.
Yes. Yeah. And it means that we have to invest there to expand the substation in Vestirol in order to be able to put the new lines, to connect the new lines or the generation capacities to be transported across the Austria and Europe.
Another area I want to probe into, which is, I would say, a hot topic across all different industries, not just the utility industry, but the whole subject matter of AI and artificial intelligence. And so when you look at APG, how do you employ AI in your operation? And if you do, what projects are you working on?
We started 2 years ago, I would say. The time flees.
Okay.
With a project Data-Driven Utility.
Okay.
Where we are trying to aggregate all the information, all the data, what we have in-house already, and to use them in the most possible and best way.
Okay.
According to artificial intelligence, we started right now a project which I'm following, and it's actually the usage of artificial intelligence in order to make the better condition assessment of transformer and instrument transformer following the oil analysis.
Right.
Because we have a huge base of oil analysis until now performed by human intelligence, and now we are trying to see how the artificial intelligence is matching the human, and we hope that we can match it very well in order to get more or better, not better results, but faster results on the same quality.
Are you starting to see any trends coming out of the analysis with the AI?
We just started the project, but I'm very positive that the results will be good.
Okay, that's good. Are there any other things you're looking at AI for in your utility?
Yes, but I'm not very much in focus on that. Other colleagues are covering these topics, but yes, we are using also some internal chatbots or something like that.
Yeah. Okay, just ways that
we have to be a little bit conscious how to use it.
Yeah, of course. I know we're looking at the same thing in Reinhausen, where we're looking at how we can actually capture the knowledge that's been generated over the years with all of the different expertise that we have in the company, and turning that into a chatbot so that we can actually preserve knowledge for the long term. So it's similar in that what you're looking at with chatbots, I'm sure, is similar to what we're doing.
The main reason, in my opinion, is why to go to AI supported decision making and taking is because the human intelligence is living. It's going to be retired, and nowadays we are facing the facts that the people are not staying as long in the company as it was in the past.
Right.
So in the past we had people starting the professional career with 15, 16 years with APG.
Right.
And until to the retirement. Nowadays, the fluctuation is much, much higher.
Right.
And the scale of the project is also so big that you cannot concentrate on all topics on the same way and stay focused.
Exactly. Yeah, that's a challenge for everybody. I know we talked a little bit about sustainability already, but what measures are you taking to address sustainability with an APG, particularly regarding CO2 emissions and overall environmental impact?
We are trying to use the new technologies which are responsible for less CO2 emission already during the manufacturing processes. We are trying to use the materials which are not emitting so much CO2. We are trying to extend the life cycle of the equipment, maybe also changing some paradigm and way of thinking, how it was 10 years ago.
Right.
Now, let's say maybe the transformer can live 10 or 15 years longer with proper maintenance works and strategy. That's how we can try to contribute for the sustainability as well.
Understand. And I think this ties back a little bit to what you were saying earlier about digitalization and digitalization of your assets. But how are you leveraging then to ensure for a sustainable future digital solutions within the marketplace to help you make better decisions and have more intelligence about the devices that you have on your system, whether it be transformers, whether it be circuit breakers, whether it be instrument transformers, switches, whatever else is being used in your system?
We are beginning the path of digitalization of those, let's call them very traditional and conservative assets. They have plenty of information supplying to us, and using this information in a proper way, making the analysis of this data, we can make the life cycle longer.
Right.
And that's the way how we impact that. The usage of those technology impact some other challenges, but at the end of the day, I'm convinced that we will have some positive results.
Now, I know Austria is known for its pump storage power plants. How are you leveraging this technology, and what role does battery storage solutions play in your strategy?
Yes, the pumping storage plants are mostly placed in the western part of Austria, and we are storing the energy generated by wind and solar in the east. In the western part, where there is a shortage of wind or sun, we can use this energy as well. The battery storages are not in the focus of APG at the moment, because we are talking about huge amount of energy which has to be stored, but the distribution system operator are dealing with that, are thinking about that on a lower voltage level, but mostly, let's say, also on the low voltage network, because it's much easier to store this energy which is produced here and store it locally.
Right, exactly. So more either at homes or industrial sites. Yeah, okay.
Let's make some prosumers.
Yeah, exactly.
Strategy, yes.
So maybe let's look to the future. And I know that Austrian Power Grid emphasizes that you're breaking new ground and using technological innovations to bridge deficits in grid expansion. Can you tell us more about the specific technologies and innovations you're using and how they're helping to overcome these challenges?
We are dealing at the moment with something like more than 50 research and development projects. At the moment, trying to address plenty of different areas in order to get new knowledges and to be ready for the implementation of the new technologies and to answer the challenges of the future as well.
Right.
So using the digitalization, following some natural events, what is happening now. For example, the thunderstorms combined with geomagnetical induced currents impacting the operation of the grid and the transformers. That's what are we doing now. Let's say we are focusing also not only on the network operation, but also for the development and how to support it for the future.
And are those collaborations typically with the university and say public-private type of collaboration?
Yes, we have the collaboration with universities. We have the collaboration with some other institutes, and of course the collaboration with the utilities across the Europe. But not only utilities, we are collaborating as well with the manufacturer. We are following the approach of common design thinking in order to develop a product or a solution together with the manufacturer in order to get the most benefit for both sides, and not only for us, but for the whole society.
Right, right. And I think that's just what's needed as we go forward in our industry is continued collaboration to drive the innovations needed for all of our success.
Correct.
What trends do you see shaping the future of the energy grid in your region, and how are you planning to adapt to these trends?
The higher demand of the energy. So it means that we are looking for the solution how to transmit this more energy. For example, we are using the high temperature conductors We are working with thermal rating on the lines. We are working on the dynamic load management of the transformers, implementing even more and more digital solutions in order to coordinate all those information fluid as well.
Yeah, exactly. So it sounds like you only have a few things going on. No, it's a lot. It's it's a lot to manage, right? From your side as an asset manager?
It's a lot to manage, yes. Because we have to be present now.
Right.
To make the grid operating, but also to always to have a view or focus in the future to see what are we expecting.
Yeah.
And how to manage the new challenges.
It's a crazy and amazing challenge as you go forward.
Definitely.
Well, I just want to thank everybody for joining our first episode of Season 2 of Power On. We invite you to go back and watch or listen to our Season 1 episodes as well at your convenience. I'd especially like to thank Fredi for joining us today for this fascinating discussion on the challenges and opportunities at the Austrian power grid. So, Fredi, thank you so much for being here today.
Thank you very much for an invitation. It was a very big pleasure to have such a discussion with you. Thank you very much. And
you're a fantastic guest, so thank you for
everything.
Much. Until the next episode, Power On.